So let's see this. So in this question, a relation is given to you. In this relation, there are total 6 attributes, A, B, C, D, E, F. This is the relation schema. Okay. So what we call it? We call it relation schema. So this is called relation schema. So, and what is the arity of this relation? So this is called relation schema. This is called relation schema, or you can call it scheme. Okay. And what is the arity for this relation? The arity, or you can say degree, degree of this relation is basically 6. So there are 6 attributes, and the question is saying that AB is a composite primary key. Okay. I told you what is a composite. Tell me what composite means. When composite means at least 2 attributes. Okay. Composite means at least 2 attributes. At least 2 attributes. So this is your composite. Okay. So I told you what is, there are 2 type of candidate keys. Yes or no? There are 2 type of candidate keys. One is composite, one is simple. Simple candidate key means only 1 attribute, and composite candidate key means at least 2 attributes. Okay. So in the question, it is given that A comma B. So this is a composite primary key. Remember, this does not mean that A is a primary key, B is a primary key. It means that A comma B, this combinedly, this is a primary key. Okay. This combination is a primary key. Is this clear to everyone? Okay. So this combination AB is the primary key. Now, okay, so this is a primary key, and the following functional dependencies. These functional dependencies are given to you. One thing I again want to tell you, that remember, when we say that when we say that FD you have, and when we say X is a from X to Y, then you know this is a set of attribute, right? Correct. Okay, so from set of attribute to set of attribute, you can have, this is set of attributes. From set of attributes to set of attributes, this is also set of attributes. So from set of attributes to set of attributes, you can have set of functional dependency. This is you can have functional dependency. You can have this functional dependency. For example, remember when I say like this, when I say AB determines C, this is just a convenient representation. Yes or no? This is just a convenient. Okay, this is just a convenient. This is just a convenient representation. Okay, this is just a convenient notation. Remember, this is just a convenient notation. What actually it means? Tell me what actually it means. It actually means that A comma this set of attributes determining set of attributes. Okay, this actually means set of attributes determining set of attributes. So remember, this is actual because this X is set of attributes. Y is set of attributes. So you can notice this is set of attributes. You can notice this is set of attributes. So is this clear to everyone? Tell me, is this clear to everyone? So remember, this is just a convenient notation. Conveniently, we say that AB determining C. This is same as saying that A comma B, this set determines this set. So here, remember, it does not mean, remember, it does not mean that A determines C and B determines C. Yes or no? Clear? Okay. It does not mean that A determines C and B determines C. Okay. It does not mean this. Okay. So this is the idea. So remember this point. So this is just a convenient notation. So this is a point. Okay. Anyway, now remember, so here it means that AB, this combination AB determines C, D, E, F. Okay. And the question is saying that E determines D and C determines F. So find the answer. Can you solve this question? Tell me what will be the answer. Tell me. So AB determines C, D, E, F, E determines D, C determines F. So here, first of all, you find the candidate key. So tell me what are the candidate keys here. You can notice that A comma B is not on the RHS. These attribute A comma B, these attributes are not on the RHS. So definitely they must be present in every candidate key. And you can notice they can determine everything. So the only candidate key is A comma B. Okay, this is the only candidate key. So that is the reason I can say what are the non-prime attributes. So the non-prime attributes are basically C, comma D, comma E, comma F. These are the non-prime attributes. And now just see, okay, can subset of candidate key, can it determine non-prime attribute? Can it determine non-prime attribute? Just check this. Can it determine non-prime attribute? This subset. Okay, this is for 2NF. What you will do? For 2NF, just find out this. Okay, just find out this. What you find out? Just find out this proper subset. Okay, proper subset of candidate key. Okay, closure. Okay, and you see in this closure, do we have non-prime attribute or not? In this, do we have non-prime attribute or not? In this closure, do we have non-prime or not? On non-prime or not? Okay. So basically, this is the idea. Okay. Just find the, so what is A plus? Tell me. This is the proper subset of candidate key. This is the candidate key. So this is the proper subset of candidate key. Now, in the proper subset of candidate key, that is A, B, A. What is A plus? That is A. And what is B plus? That is B. So here you can notice that this is in 2NF, correct? Okay, so your relation R is in 2NF. Your relation is definitely in 2NF in the second normal form. There is no problem. Okay, another method. Okay, the method number 2. What is the method number 2? That is, there is no such partial dependency. Yes or no? Candidate key determining non-prime attribute. Candidate key determining non-prime attribute. Non-prime attribute. This is not a partial key here in this R. Yes or no? Okay, no such partial. This is not a partial key. This is not a sorry. This is not a partial FD in R. Correct? Yes or no? Is this clear? There is no such partial FD in R. In the relation R, there is no such partial FD. This type of partial FD we do not have. Is this clear? This type of partial functional dependency, there is no such partial functional dependency in R. No such, I can say no such partial functional dependency in R. So I can say this is in 2NF. And what about 3NF? What about 3NF? Look at this. Look at this. This is not a super key. Look at this. This is not a super key. And look at this. This is non-prime. Okay. Look at this. This is non-prime. This is non-prime. So, okay, not a super key determining non-prime. Not a super key. Not a super key determining non-prime. So this is not in 2NF. Okay. This is not in 3NF. This relation is not in 3NF. So this is in 2NF, but not in 3NF. This is in 1NF also. This is in 2NF also. Okay. The relation is in 2NF also. Okay. So the answer will be this. Is this clear to everyone? Please tell me. This can never happen. Yes or no? This can never happen. This can never happen. This thing can never happen, right? This thing can never happen. Okay. So this is your answer. Very simple question. Now let's see the next. Now let's see some questions on this. Like functional dependency is satisfied on a relation instance. Okay. Sometimes functional dependencies are satisfied by relation instance, but they are not satisfied by the relation schema. So we will see functional dependencies satisfied by relation instance versus functional dependencies satisfied by relation schema. Okay. Remember the same thing. When I say relation, what it means? When I say relation, what it means? If I only say relation, it means relation schema. Okay. When I say relation, remember, if I only say relation, it simply means I am talking about relation schema. It means we are talking about relation schema. Okay. So relation schema, or you can say scheme. And this relation instance, this is also called relation extension. The another name is relation extension. Okay. So this is called relation instance, and this is your relation schema. So these are two things. Okay. Anyway, now let's see. So what I'm saying that this is your topic, that functional dependency is satisfied by relation instance and functional dependency is satisfied by relation schema. Tell me one thing. Just tell me a simple thing. If a functional dependency is satisfied by a particular instance, okay, if a FD is satisfied, if this functional dependency is satisfied by a instance, by a particular instance, then what can I say about this is satisfied by what can I say about satisfied by relation? Satisfied by the relation, or I can say schema. What can I say? So functional dependency, the same. Okay, you have some functional dependency. Let's assume F. Let's assume you have some functional dependency F. Let's assume you have some functional dependency F. So tell me here what you can say. If it is satisfied by particular instance, if Okay, if a particular instance is satisfying it, a particular instance is satisfying it, then it may or may not. Yes or no? It may or may not. I can say may or may not. Yes or no? May or may not. So I can say this does not imply. Okay, I can say may or may not. So if functional dependency, some functional dependency, it is satisfied by a particular instance, it does not mean that it is satisfied by the schema. Okay. The second point, if it is satisfied by schema, then can I say it will be satisfied by every instance? If it is satisfied, then it will always happen. Okay, it will always happen. If it is satisfied by the by the schema itself, if the schema itself is satisfying it, then I can say it is satisfied by it is satisfied by every any particular instance. Okay, tell me another. If it is not satisfied, if it is not satisfied, then if it is not satisfied, if it is not satisfied by instance, there is a particular instance, it is not satisfying this. If a particular instance is not satisfying this, then I can say it will not, I can say it will not be satisfied by schema also. Okay, very simple. And what about this? If it is not satisfied by schema, if it is not satisfied by schema, then what can you say about the instance? If it is not satisfied by the schema, if it is not satisfied by the schema, then it may or may not be satisfied by a particular instance. Yes or no? Then it may or may not be satisfied by particular instance. May be satisfied by a particular instance. Correct? May be satisfied by a particular instance. Is this clear to everyone? Another thing, tell me, if it is satisfied by every instance, if it's satisfied by every instance, if it is satisfied by every relation instance, if it is satisfied by every relation instance, now what you can say? If it is satisfied by every, I am saying if it is satisfied by every relation instance, if it is satisfied by every relation instance, then it will be satisfied by schema also. Okay, so this is the correspondence. Is this clear? If it is satisfied by every relation instance, then it will be satisfied by schema. And if it is satisfied by schema, then it will be satisfied by every relation instance. Yes or no? Clear? Tell me, this is bijection. This is bijection. This is bijection. Okay, so this is your if and only if bijection. Okay, now let's move on. So let's see this question. Tell me the answer here. This relation is given to you, relation instance is given to you. Okay, the relation instance is given to you. Now the question is asking which of the following may hold. Is the question talking about relation or relation schema? A relation instance or relation schema? Is the question talking about relation or relation instance? Schema or instance? No, the question is talking about schema. That is the reason the question is saying may hold on the relation. That is the reason question is saying may hold on the relation. It may or may not hold. Yes or no? It may or may not hold on the schema. Is this clear to everyone? It may or may not hold on the schema, but the question is asking which of the following may hold on the relation. Okay, which of the following may hold in the above relation? So tell me, which of the following may hold? What about this AB determining C? May it hold on the original relation? On the original relation? Okay, so you can notice AB determining C. So you can notice here you can notice AB value is same, but C value is different. So this can never hold. I can say this can never hold. Yes or no? Does not hold. I can say this does not hold. I can say this does not hold on relation schema. It does not hold on relation schema. I can say it does not hold on relation schema. Yes or no? It does not hold on the relation schema. Next, what about C determining AB? C determining AB. So you can notice here value of C is same and value of AB is also same. Value of AB is also same. Here also value of C is same. Value of AB is also same. Okay. What about C4, C4. Here value of C is the same. Value of AB is also same. So here I can say this may hold. I can say yes or no. This may hold. This may hold on relation schema. Agree or not? Yes or no? This may hold. May or may not. I don't know. This may hold. May or may not. Correct or not? This may or may not hold. So this may or may not. So I can say this may hold on relation schema. What about this one? So this may hold. Remember, I am not saying that this will hold. Okay, please understand the difference between may versus will. Okay, I am not saying that this will hold. I am saying this may or may not hold. Or may not. May or may not. May or may not. Okay, what about the next? What about the next? B determining C. B determining C. Okay, it will not hold. It does not hold. Yes or no? It necessarily does not hold. What about AC determining B? AC determining B. 10C1. Okay, so 10C1, 10C1, 10C1. Next, I2C4, I2C. So this may hold. This may hold. Okay, and what about BC determining A? What about BC determining A? B1C1, 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 B3C4. And okay, so this also may hold. Yes or no? This also may hold. So remember, these may hold. Remember, these may or may not hold. I can say these may hold on relation. These may hold on relation, but this will not hold all on relation. I can say this will not hold, does not hold. Okay, does not hold. Is this clear?